We've seen now examples of why we would want to combine vector functions. We might also want to combine vector functions with scalar functions. Examples that we just looked at, we could do f of t equals f of t dot g of t, and we just saw, or at least I just stated, how we could take the derivative of this function, or n of t equals f of t cross g of t. Of course, we can do, say, r of t equals f of t plus g of t. We've already done this for r1 of t plus r2 of t, and we see how the sum of two vector functions can work, and it's easy to verify that the derivative of the sum is the sum of the derivatives. We can do composites. So let's consider a composite. First of all, let's consider f of h of t. Now we can't, if f of t is a vector function, we can't do a composite of f of t with g of t because f acts on scalars, just plain old numbers in this case. G is a vector, so we can't do f of g of t, at least not for these functions. Our vector function can't be evaluated for another vector. It wouldn't make sense. Anyhow, okay, we could do f of h of t, and let's let that function be what the heck, phi of t. Maybe not the best choice of symbol, but that's okay. Then phi prime of t is going to be just what we'd expect. And the reasons, again, are not difficult to understand, but we'll get into those later. It's just going to be h prime of t times f prime of h of t, just like the chain rule for functions of a single variable. We could do the function gamma of t, just to introduce a few foreign symbols that are going to be important in a lot of your courses. Gamma of t, let that be h of t times f of t. Then what's gamma prime of t? Well, if the product rule holds, and I'll let you determine whether this is the case, but that should be h prime of t f of t plus h of t f prime of t. Again, it's not difficult to understand why these rules hold. Basically, they hold because if you write these functions out as x of ti plus y of tj plus z of tk form, and write out what the dot product is and then take the derivative of that, it turns out to be exactly what you get if you apply the product rule in the way we've just seen.